This video discusses solving equations by factoring using something called the zero product property. This property is extremely important in algebra, and basically what it says is if I have a product, let's say A times B, and that product equals 0, then one of those two factors has to equal 0. For example, if I had something like 5 times some number, and I'm not sure, I don't know what that is, equals 0, I know that that would have to be a 0, because the only way to multiply something together to get 0 is to have one of the factors be 0. So what zero product property says is if you don't know either of the factors, if both of the factors are unknown, then that means that one of the two factors has to be 0. So if A times B equals 0, then either A equals 0 or B equals 0. So basically what we're going to do is find the factors, create a product, and then set both of them equal to 0 to solve to see what our options might be. This will make more sense when we get into an example. All right, let's take a look at these first simple trinomials. In this first example, I have x squared plus 5x minus 6 equals 0. I'm going to check for GCFs. There aren't any. No red flags. It's already in descending order. My leading coefficient is 1, and so this should be pretty simple to factor out. So all I need to do for this example is find the factors of 6. That would be 1 and 6 and 2 and 3. Because both 1 and 6 and 2 and 3 can create a 5, I'm going to need to test out the signs. I'm creating a positive 5. That would be positive 6 and negative 1, or both positive 2 and positive 3. Because this is negative, I know that one of the signs had to be negative, so it's got to be that first set. And so this factors to x minus 1 times x plus 6, and don't forget the equals 0. On this particular one, my factors are x minus 1 and x plus 6. Well, using the zero product property, this thing is like A and this thing is like B. If this times this equals 0, then either this equals 0 or this equals 0. And so that's basically all I'm going to set up. I'm going to take my individual factors and I'm going to set up two equations based off of them, because one of those had to have been 0. What would x have to be in order to make this 0? Well, using simple inverse operations, I find that x could equal 1. Using inverse operations down here, x could equal negative 6. Both of these answers would satisfy this equation, resulting in a true statement. Let's test it out really quickly. If x were to equal 1, I'd have 1 squared plus 5 times 1 minus 6 equals 0. 1 squared is 1, plus 5 times 1 is 5, minus 6 equals 0. 1 plus 5 is 6, and 6 minus 6 equals 0, so that's a true statement. If x were to equal negative 6, I would have the quantity of negative 6 squared, being really careful to also square the negative, plus 5 times negative 6 minus 6 equals 0. Negative 6 squared is positive 36, plus 5 times negative 6 is negative 30. And then minus 6 equals 0. 36 minus 30 is 6. Minus 6 is 0. That is a true statement. So both of these answers could be true. Here's the cool thing. Remember when we talked about degree and how I said degree was going to end up being important? The degree of the polynomial actually tells you how many answers you should have, how many different things could be a solution to the equation. So the degree of this polynomial is 2, because while there are 3 terms, that is the highest degree on any of the 3 terms, and so I have 2 potential answers. Now, for some of these examples, you might have 2 answers, 1 or no answers, and we'll talk about those cases in class. However, if you have 3 answers, you know that you didn't do the right thing, because the highest power here is only 2. Let's look at these examples. Some of these can be pretty simple, but we're just going to factor the expression get everything set equal to 0 and factor the expression like we normally would, testing out for GCFs, looking for special factor patterns, and then factoring using our other methods if we can. The key with zero product property is knowing its name. It's a product that equals 0. So you have to have a 0 in here. If you look at example 3, there's no such thing as a 36 product property. So I would need to get that equation to be set equal to 0. Let's go through example 2 first. I have it, the expression equaling 0, so I'm ready to go. Do I have any GCFs here? I do. I have a 5y in common. When I factor out a 5y, I'm left with y plus 2 equaling 0. I double check inside those parentheses to make sure that I can't do anything else, and I cannot. Do I have a product? I do. And is that product set equal to 0? Yes. So now I just need to identify what the factors are. The factors would be 5y and y plus 2, and then I set those factors equal to 0. And then I just use my inverse operations to solve. 5y equals 0. I can divide both sides by 5, and I get y equals 0. Remember, 0 divided by 5 is 0. And then I use inverse operations here, subtract 2 from both sides, and I get y equals negative 2. A quick check shows me that both of these answers will satisfy that equation. Now let's look at example 3. Remember, we don't have a 36 product property, so what I need to do first is use inverse operations to isolate the expression and get that expression set equal to 0. So then I have 4x squared minus 36 equals 0. As always, we're going to double check for GCFs and special factor patterns first. I do have a GCF, that would be 4, and I'm left with x squared minus 9 equals 0. And then I am going to double check for special factor patterns inside that parentheses, and I have a difference of 2 perfect squares. That leaves me with 4 times x plus 3 times x minus 3 equals 0. Now, how many factors do I have here? Well, technically I have 3 of them. 4 is a factor, x plus 3 is a factor, and x minus 3 is a factor. However, what was the degree? The degree was 2, so at most I'm only going to have 2 answers. And you can kind of see that if I were to take this first factor and set it equal to 0, that makes absolutely no sense. 4 equals 0 doesn't make any sense. We don't need to test out constant factors, only ones that contain variables. So my factors that I'm going to test, x plus 3 could equal 0, or x minus 3 could equal 0. Using inverse operations, I can find that x could have been 3, or it could have been negative 3. And there are my 2 answers that could have satisfied this equation. And all you'd have to do is plug those back into the original equation, test them out, and see what could have made this become 0 or this become 0. If you feel comfortable with this, you can go ahead and pause and try these 2 on your own. In example 4, there are no GCFs, no red flags, and it's already in descending order, no special factor patterns, so I am ready to factor. The factors of 3x are 1x and 3x, and the factors of negative 2 are 1 and 2. Only options for each one of those. That's going to make this pretty quick to test out. I'm going to go ahead and place, excuse me, I sneezed. Place the 3x and the 1x and test out the 1 and the 2. Let's start by putting the 1 here and the 2 here. If I were to do that, the outsides would be 6x and the insides would be 1x. I know I need to create a negative 5x, so that would have to be negative 6x and positive 1. And so that would make this negative positive. And the last thing I need to do is double check to make sure that this sign is right. A positive 1 times a negative 2 does result in a negative 2. If you don't get a negative 2, then you need to switch and try it again. So if you had tested out with the 2 in that first group and then the 1 in the second group, you would have gotten a positive 2. And it just means that you need to adjust the order of the factors. I've got my equals 0 part here, and so now I just set each factor equal to 0 because I know I factored it correctly, and I solve. Using inverse operations, I subtract 1 from both sides, and I get 3x equals negative 1. Divide both sides by 3, or multiply by 1/3, and I get x equals negative 1/3. That is one of my answers. Using inverse operations on the second factor, I get plus 2, add 2 to both sides, and I get x equals 2. And there are my two answers. You can plug those back in and double check and make sure that they result in true statements. In example 5, you do need to do some ordering, get it set equal to 0, and take out any GCFs. There aren't any special factor patterns or red flags. Go ahead and try that now. Let's make note here that the degree is 3, which means I should have 3 answers when I'm all said and done with this. Okay, so I need to find the factors of 6x squared. That'd be 1x and 6x, 2x and 3x. I'm just ignoring this GCF factor of x out here for now. I need to find the factors of 12. That's 1 and 12. 2 and 6, 3 and 4. And doing some quick tests, I can easily figure out which set of factors can multiply and then add or subtract to create the negative 17. Factoring this, I will find that 3x minus 4 and 2x minus 3 work. That gives me a negative 9x and a negative 8x, and those add to create a negative 17x. Don't forget to put your equal 0, and don't forget to drop down your GCF factor. Now I have 3 factors that need to be set equal to 0. I've got the outside factor of x equals 0. This one I need to pay attention to because that is the variable. I've got 3x minus 4 equals 0, and I've got 2x minus 3 equals 0. Using inverse operations, I can see that that is already an answer. I don't have to do anything there. Add 4 to both sides, and then divide by 3, and I get x equals 4/3, positive 4/3, and then add 3 to both sides, and divide by 2, and I get x equals 3/2. And there are my 3 answers. You can plug those back in to check. Here's one for you to try on your very own. Don't forget to factor out the GCFs. Here's the solution. Double check your work and come to class with questions.